There are four drivers behind virtualization. These are that hardware is not used fully. Second is that data centers get very crowded. Third are energy costs and system administration costs. I'm going to look at these issues in turn. So firstly, when we look at hardware, we know that computing doubles about every 18 months or something, and that's been approximately true for 40 years, the so-called Moore's law. Now, software changes a lot more slowly than that, so quite often companies will have software which at one time was demanding on their hardware and now is very little. So we've got various packages and version requirements, such as Windows servers, Unix and the variants. And these very often take up very little space, actual runtime for that hardware. So now there are physical issues to consider. Firstly, data centers have are physical spaces. Physical spaces incur costs. So if you just continually increase the number of servers for different applications, you end up with higher infrastructure costs. And those aren't just the costs of building, also security, and we have power issues. So if each server consumes, say, a kilowatt, that's output as heat, you need the equivalent energy in cooling. And energy costs turn out to be quite significant. So if you can somehow take your different applications and put them onto the same virtual machine, you can reduce your costs significantly. Don't discount system administration costs. So if we have a data center, we require specialist staff. These staff probably will look at multiple operating systems. These need to be patched, maintained, backup, and so on. So if you've got virtualization going on, you're trying to back up some large server, then you can do it all as one shot rather than having multiple servers requiring multiple backups. So the advantages of virtualization is because it is you're turning your whole computer into software. Essentially, you can copy the whole of that machine state in what is called a snapshot. And that means that if you have some issue around hardware failure or something like that, you'll have backed up the complete state of the hardware and you can restore it very quickly. Snapshots also provide great security defense. So if somebody you causes a virus incident on your servers and you've got snapshots, you can basically restart a different server and recover from that snapshot without losing very much work. Now, one key issue that we're going to meet in cloud are what are called virtual appliances. So these are virtual machines where the software is pre-configured. Though we're quite used to the idea of installing packages on our local Windows machine, and that's not particularly demanding, when we're looking at enterprise software which has multiple hardware software dependencies, configuration can be quite time demanding. So if we can actually use a pre-built virtual appliance with the software already configured for some abstract machine, that can be actually a great time saver. Disadvantage is, of course, because we've got an additional software layer, that will reduce system speed, though there are lots of tricks these days which reduce that delay to something less than 10%. We can't necessarily tune for hardware, so if we know there is some particular underlying hardware that we can use on a particular device, we can't adjust our software to take advantage of that because the software and the hardware layer are separated with this virtual machine. License costs remain the same. So if we take a large database supplier, that will have the same charges irrespective of whether we're running on a virtual or a physical machine. And in fact, if you run on, you've got two virtual machines running on one physical machine, you will pay for both of those virtual machines. Looking then at containers, we've seen some of the advantages and disadvantages of virtual machines. Because virtual machines emulate down to the hardware layer, they're always active, and that means there's a limited number of virtual machines we can run on the same hardware because each one takes some capacity. The idea of containers is actually we take our application code, operating system, split that up into different layers, and then it runs in the same memory space as the underlying hardware. But it doesn't emulate the hardware, it emulates all the operating system layers and so on. So we can have containers with pre-built software included, and this can be very much more efficient. So the advantages of containers that could share a kernel or application libraries very widely, much lower operating system overhead than virtual machines. So a virtual machine is quicker to start than a physical machine, but there is the time taken to boot an operating system, load code into it. Virtual machines will start instantly, essentially. So they generally give the same or better performance compared to a virtual machine. And one thing we can do with virtual machines is we can run multiple different software configurations which are possibly in conflict. And this is something which is called dependency hell. So very often when you go online, you'll look at some complex package and they will say the easiest way to install this is to use our container. So once you've got the container system running, generally Docker, you can install multiple containers which essentially would have conflicting requirements if you were to install that software physically. Disadvantage of containers is they do require an additional installation, but once you've got Docker, that's the one that we'll be using on this module, once you've got that installed, then you can install any number of containers as you require. Although it's quite rare, they are running in the same physical space, same memory space as the host, so a broken container could bring your host down. Another disadvantage is you do need to be a bit careful with containers as they do tend to start proliferating, and if they do, they will use your disk space.